Chapter 31 of Astronomy, the Science of the Heavenly Bodies, by David Todd. The Solar Corona. And what is the sun's corona? Mildly asked a college professor of a student who might better have answered, not prepared. I did know, professor, but I have forgotten, was his reply. What an incalculable loss to science, returned the professor with a twinkle. The only man who ever knew what the sun's corona is, and he has forgotten. Only in part has the mystery of the corona been cleared by the research of the present day. Our knowledge proceeds but slowly because the corona has never been seen except during total eclipses of the sun, and astronomers, as a matter of fact, have never had a fair chance at it. 2 total eclipses happen on the average of every 3 years. Their average duration is only 2 or 3 minutes. Totality can be seen only in a narrow path about 100 miles wide, though it may be several thousand miles long. There is usually about equal chance of cloud with clear skies, and fully 3/4 of the totality areas of the globe are unavailable because covered by water. So that even if we imagine the tracks of eclipses quite thickly populated with astronomers and telescopes, at least one every 100 miles, how much solid watching of the corona would this permit? Only a little more than 1 week's time in a whole century. The true corona is at least a triple phenomenon, and a very complex one. The photographs reveal it much as the eye sees it, with all its complexity of interlacing streamers projected into a flat or plane surrounding the disk of the dark moon, which hides the true sun completely. But we must keep in mind the fact that the sun is a globe, not a disk, and that the streamers of the corona radiate more or less from all parts of the surface of the solar sphere, much as quills from a porcupine. From the sun's magnetic poles branch out the polar rays, nearly straight throughout their visible extent. Gradually, as the coronal rays originate at points around the solar disk farther and farther removed from the poles, they are more and more curved. Very probably they extend into the equatorial regions. But it is not easy to trace them there because they are projected upon and confused with the filaments having their origin remote from the poles. Then there is the inner equatorial corona, apparently connected intimately with truly solar phenomena, quite as the polar rays are. The third element of the composite is the outer ecliptic corona, for the most part made up of long streamers. This is most fully developed at the time of the fewest spots on the sun. It is traceable much farther against the black sky with the naked eye than by photography. Without any doubt, it is a solar appendage, and possibly it may merge into the zodiacal light. Naturally, this superb spectacle must have been an amazing sight to the beholders of antiquity, who were fortunate enough to see it. Historical references are rare. Perhaps the earliest was by Plutarch about AD 100, who wrote of it, "A radiance shone round the rim, and would not suffer darkness to become deep and intense." Philostratus, a century later, mentions the death of the Emperor Domitian at Ephesus as announced by a total eclipse. Kepler thought the corona was evidence of a lunar atmosphere. Indeed, it was not until the middle of the 19th century that its lack of relation to the moon was finally demonstrated. Later observers, Wyberd in 1652 and Ulloa, got the impression that the corona turned round the disk Catherine wheel fashion, like an ignited wheel in fireworks turning on its center. But no later observer has reported anything of the sort. Quite the contrary, there it stands against the black sky in motionless magnificence, a colorless, pearly mass of wisps and streamers, for the most part nebulous and ill-defined, fading out very irregularly into the black sky beyond, but with a complex interlacing of filaments, sometimes very sharply defined near the solar poles. It defies the skill of artist and draftsman to sketch it before it is gone. Photograph it? Yes, but there are troubles. Of course, the camera work is superior to sketches by hand. As Langley used to say, the camera has no nerves, and what it sets down we may rely on. Foremost among the photographic difficulties is the wide variation in intensity of the coronal light in different regions of the corona. If a plate is exposed long enough to get the outer corona, the exceeding brightness of the inner corona overexposes and burns out that part of the plate or film. If the exposure is short, we get certain regions of the inner corona excellently, but the outer regions are a blank because they can be caught only by a long exposure. So the only way is to take a series of pictures with a wide range of exposures, and then by careful and artistic handiwork combine them all into a single drawing. Wesley of London has succeeded eminently in work of this character, and his drawings of the sun's corona, visible at total eclipses from 1871 onward, in possession of the Royal Astronomical Society, are the finest in existence. They give a vastly better idea of the corona as the eye sees it than any single photograph possibly can. The early observers apparently never thought of the corona as being connected with the sun. It was a halo merely, and so drawn. Its real structure was neither known, depicted, or investigated. Sketches were structureless, as any aureola formed by stray sunlight grazing the moon might naturally be. That the rays are curved and far from radial around the sun was shown for the first time in the sketches of 1842. And in 1860 Sir Francis Galton observed that the long arms or streamers do not radiate strictly from the center. The inner corona had first been recorded photographically on a daguerreotype plate during the eclipse of 1851, but the lens belonged to a heliometer and was of course uncorrected for the photographic rays. The wet collodion plates of the eclipse of 1860 by de la Rue proved that not only the prominences but the corona were truly solar, because his series of technically perfect pictures revealed the steady and unchanged character of these phenomena while the moon's disk was passing over them as totality progressed. And at the eclipse of 1869, Young put the solar theory of the corona beyond the shadow of any further doubt by examination of its light with the spectroscope, and discovering a green line in the spectrum due to incandescent vapor of a substance not then identified with anything terrestrial, and therefore called coronium. The total brilliance of the corona was very differently estimated by the earlier observers, though pretty carefully measured at later eclipses. The standard full moon is used for reference, and at one eclipse the corona falls short of, while at another it will exceed the full moon in brightness. Variations in brilliancy are quite marked. At one eclipse it was nearly 4 times as bright as the full moon. Much evidence has already accumulated on this question, but whether the observed variations are real, or due mainly to the varying relative sizes of sun and moon at different eclipses is not yet known. The coronal light is largely bluish in tint, and this is the region of the spectrum most powerfully absorbed by our atmosphere. Eclipses are observed by different expeditions located at stations where the eclipsed sun stands at very different altitudes above the horizon. Besides this, the localities of observation are at varied elevations above sea level, so that the varying amount of absorption of the coronal light renders the problem one of much difficulty. The long ecliptic streamers of the corona were first seen by Newcomb and Langley during the totality of 1878. On one side of the sun there was a stupendous extension of at least 12 solar diameters, or nearly 11 millions of miles. Langley observed from the summit of Pikes Peak, over 14,000 feet high, and was sure that he was witnessing a real phenomenon heretofore undescribed. The vast advantage of elevation was apparent also from the fact that he held the corona for more than 4 minutes after true totality had ended. These streamers are characteristic of the epoch of minimum spots on the sun, as Ranyard first suggested. It was found that this type of corona had been recorded also in 1867, and it has reappeared in 1889, 1900, and 1911, and will doubtless be visible again in 1922. How rapidly the streamers of the corona vary is not known. Occasionally, an observer reports having seen the filaments vibrate rapidly, as in the aurora borealis, but this is not verified by others who saw the same corona perfectly unmoving. Comparisons of photographs taken at widely separate stations during the same eclipse have shown that at least the corona remains stationary for hours at a time. Whether it may be unchanged at the end of a day, or a week, or a month is not known, because no 2 total eclipses can ever happen nearer each other than within an interval of 173 days, or 1/2 of the eclipse year. and usually the interval between total eclipses is twice or 3 times this period. Theories of what the solar corona may be are very numerous. The extreme inner corona is perhaps in part a sort of gaseous atmosphere of the Sun, due to matter ejected from the Sun and kept in motion by forces of ejection, gravity, and repulsion of some sort. Meteoric matter is likely concerned in it, and Huygens suggested the debris of disintegrating comets. Schuster was in agreement with Huygens that the brighter filaments of the corona might be due to electric discharges, but it seems very unlikely that any single hypothesis can completely account for the intricate tracery of so complex a phenomenon. Elaborate spectroscopic programs have been carried out at recent eclipses, affording evidence that certain regions are due to incandescent matter of lower temperature than the Sun's surface. A small part of the light of the corona is sunlight reflected from dark particles, possibly meteoric, but more likely dust particles or fog of some sort. This accounts for the weakened solar spectrum with Fraunhofer absorption lines, and this part of the light is polarized. Many have been the attempts to see or photograph the corona without an eclipse. None of them has, however, succeeded as yet. Huygens got very promising results nearly 40 years ago, and success was thought to have been reached. But subsequent experiments on the Riffelberg in 1884 and later convinced him that his results related only to a spurious corona. In 1887, the writer made an unsuccessful attempt to visualize the corona from the summit of Fujiyama, and Hale tried both optical and photographic methods on Pikes Peak in 1893 without success. He devised later a promising method by which the heat of the corona in different regions can be measured by the bolometer, and an outline corona afterwards sketched from these results. Still another method of attacking the problem occurred to the writer in 1919, which has not yet been carried out. It would take advantage of recent advances in aeronautics, and contemplates an artificial eclipse in the upper air by means of a black spherical balloon. This would be sent up to an altitude of perhaps 40,000 feet, where it would partake of the motion of the air current in which it came to equilibrium. Then a snapshot camera would be mounted on an aeroplane in which the aviator would ascend to such a height that the balloon just covered the Sun, as the Moon does in a total eclipse. With the center of the balloon in line with the Sun's center, he would photograph the regions of the sky immediately surrounding the Sun, against which the corona is projected. As the entire apparatus would be above more than an entire half of the Earth's atmosphere, the experiment would be well worth the attempt, as pretty much everything else has been tried and found wanting. Needless to say, the importance of seeing the corona at regular intervals whenever desired, without waiting for eclipses of the Sun, remains as insistent as ever. End of Chapter 31.